So the Airbus A380 wing design significantly affected its performance both positively and negatively. The A380's wing, while advanced for its time, also presented some challenges that affected its overall efficiency and operational capabilities. The positive impacts of the wing of Airbus A380 are as follows. Reduced drag and improved aerodynamics. The A380's wing design incorporates features like advanced aerodynamic shaping and supercritical airfoil profiles, which minimize drag and improve lift. This contributes to better fuel efficiency and a longer range. Flexibility and adaptability. The wing's design allows for flexibility and adaptability to different flight conditions, leading to smoother rides and further enhancing fuel efficiency. Advanced materials. The use of light and anti-corrosive aluminum-lithium alloys in the fuselage and advanced materials in the wings contributes to weight reduction and improved performance, according to Airbus. So let's talk about the negative impacts of the wing design of the A380. When it comes to the aspect ratio, the A380 actually has a relatively low aspect ratio, which is basically the wingspan divided by the average chord, especially when you compare it to other modern airliners like the 787, 777X, or the A350. This lower aspect ratio can result in a higher stall speed, and it might impact takeoff and landing performance as well as efficiency at certain speeds. Now, looking at wing thickness, the A380's wings are thicker from front to back than what you'd see on many other airliners. This is partly because of the low aspect ratio, and also due to the need to fit in a large volume of fuel and meet the structural requirements for such a massive aircraft. But this thicker design can also affect aerodynamics and might increase drag. Now, moving on to wingtip design. While winglets are usually great for fuel efficiency and overall performance, the A380's wingtip design, or, well, the lack of a more advanced one, has actually been a pretty hot topic among aviation experts. Some folks argue that a different wingtip design could have further reduced drag and improved performance. And then, there's the sheer weight and size of the thing. The A380 is a massive aircraft, and of course, its wings are just as large and heavy. This can really affect maneuverability and operational flexibility, especially at airports that have certain restrictions. So the A380 has experienced some issues with wing cracks, particularly in the wing rib feet. This is mainly due to a combination of material choice, thermal distortion, and assembly stresses. While, these issues have been addressed with design modifications, they do highlight the challenges of designing and manufacturing such a large and complex wing. The viability of the Airbus A380 in today's civil aviation industry can be assessed through several factors. Demand for long-haul air travel was actually one of the main reasons the A380 was designed for high-capacity long-haul routes and, well, demand for such flights remains. However, the growth rate has fluctuated, particularly due to factors like economic conditions and the impact of the COVID-19 pandemic. There's also the shift to smaller aircraft by airlines, leading them to reconsider how they deploy capacity. Many airlines are opting for twin-engine jets capable of long ranges, which can serve multiple routes with greater operational flexibility. So when it comes to operational costs and fuel efficiency, the A380 is actually less fuel efficient compared to newer models like the Boeing 787 and the Airbus A350. And, as fuel prices keep rising, airlines are becoming more and more concerned about operating costs, which, makes the A380 a bit less attractive. Now, looking at crew and maintenance costs, operating a larger aircraft means you've got higher crew requirements, more maintenance, and even higher airport fees. All of these things can really impact profitability. Some airports are, limited in their capacity to handle the A380 due to gate configurations and runway size. As a result, airlines really have to evaluate whether they can adequately serve the aircraft at their chosen airports. Some airlines like Emirates, Singapore Airlines, and Qantas have continued to operate the A380, mainly because of its spaciousness and passenger comfort. These airlines have strategic routes where demand actually supports the A380's capacity. The COVID-19 pandemic significantly impacted air travel, leading to a temporary reduction in demand for large aircraft. While the industry is recovering, the pace and nature of recovery definitely influenced the A380's viability. As airlines adapt to changing market conditions, there's potential for the A380 to, find a niche in dedicated routes with high passenger demand, especially in markets with limited competition. Some operators are converting A380s for cargo use, capitalizing on their large capacity to meet e-commerce and freight demands. The Airbus A380's viability in today's civil aviation industry is, honestly, a mixed picture. While it remains a remarkable aircraft, its future depends on market dynamics, changing consumer preferences, operational costs, and the ability of airlines to adapt to new realities in air travel. The aircraft may continue to operate effectively in certain markets, but overall, the trend appears to favor smaller, more efficient models.